Okay, we're going to take a look at the quadratic formula, which can sometimes be a daunting formula. We have it written out here. The quadratic formula helps us move from the standard form of a quadratic. So actually, it's important we write this out actually. So the standard form, as you might recall, is written as y is equal to a x squared plus b x plus c, okay? And the reason we have to know this is because you'll notice in quadratic formula, we have these same letters, A, B, and C. And what it allows us to do is factor a standard form of question that may be easy to factor or may be very difficult to factor. I've happened to choose one that's relatively easy, and that's the point. The point of that is to show that the quadratic formula will work with anything, even factorable questions, and then we could even go through one that's what would seem unfactorable, but is, because we can use a quadratic formula to solve it. In fact, we can use a quadratic formula to move from standard to factor form, which isn't too commonly taught. And recall that the factor form, y is equal to, make that a little smaller, a, we have our two brackets, we have bracket x minus r and x minus s, or whatever they call it in the course you're working with, okay? So we can use it to move between these two things, okay? Think of it almost as a surefire way of factoring, though might be a little more complex depending on the question. So this is the question we're working with. The first thing I want to do is just to make sure we can point out what a is, okay? And in this case, this is our a value. It's 3. What is our b value? Well, our b value happens to be -3 in this case. And finally, what is our c value? Well, c happens to be -6, okay? So what does that mean for the quadratic formula? Well, when we go to plug everything in, this says x is equal to. In other words, these x are actually the roots, okay? In fact, think of them as your r and your s for your factor form. They're the roots. The x-intercepts are equal to negative, okay, b, so I'm going to highlight the colors, plus or minus, and that one can be confusing, but what that is they say plus or minus is because when you find the square root of something, you actually get a positive and a negative answer, okay? Because when you square a negative value, it becomes positive, and when you square a positive value, it's also a positive answer. Here's the b again. Whoops, that's not what I wanted. Oh, that's going to ruin so much of this stuff. Let's try that again. Not bad. Here's the b again. So we get b squared. Subtract the number 4. Then there's the a value and the c value. And all of that is divided by the number 2 multiplied by, again, your a value. Okay? So what we're going to do next is we're going to plug in these coefficients and constant into the quadratic formula and see what it gives us, okay? So we're going to jump to a new page here to do this. 3, -3, and -6. I have to rewrite these things, otherwise I will for sure forget it. Y equals 3, -3, and -6. Okay, so when we go to plug it in, y is equal to -b. Well, in this case, that's -3. So keep that in mind, okay? That part can always be tricky to start off. Plus or minus, and well, we know this is a fraction, and it is a square root here, so I'm going to do my best to write it out very neatly. Again, we have a b value of -3, so we're going to plug that in, and that b value is going to be squared. Subtract 4 times our a value. Our a value in this case is 3. Times our c value. Our c value in this case happens to be -9. So a bit of memorizing of the formula. I mean, if you have it handy on hand, that's great. But if you do memorize it, it does speed things up a little bit. The next part here is just understanding BEDMAS, the order of operations, making sure you can carry those out, and you should be able to do this. Think of this like a -1 times -3, so you get +3. So you have +3 plus or minus, Again, we still have that square root. Okay. 3 squared, or negative 3 squared, I should say, is going to give us 9. So we get 9. And then negative 4 times 3 times negative 6. Okay, this is going to be negative 12 times negative 6, which is positive 72. I think that's positive 72. It is? Thanks. Yeah, 12 times 6. Great, thank you. And then, and it's positive because we had a negative times a positive, which was a negative, and then that's negative times a negative, so it becomes plus. And then finally, 2 times 3 is 6, okay? This little square root is actually going to end up being 81. So I'm going to write it on the side here. We know that that's going to be actually the square root of 81. So we can jump that simplification step. And we get 3 plus or minus the square root of 81 divided by 6. Okay, so here we go. Now we're getting into interesting territory. Oh, nuts, I do that often. Divided by 6. Square root of 81 we know is 9, but this is where I was talking about. The square root of 81 is actually plus or minus 9. In other words, negative 9 squared equals 81 and positive 9 squared equals 81. So we have 2 sets of answers. So we end up with 2 solutions here, okay? So this x, we'll call it root 1. So I'm going to say x subscript 1 is equal to, and x subscript 2 is equal to. In other words, I'm just trying to give you a representation of 2 different roots, okay? So when I rewrite this question, the first one we'll say is the positive one. So we'll say 3 plus 9 over 6. And in the second one, we're going to say 3 minus 9 over 6, okay? So it's really important that you pay attention to the operations. I put a plus operation in one and a subtraction operation in the other, okay? From here, it's, relatively simple math. 3 plus 9 is 12 divided by 6 is going to give us 2. And 3 minus 9 gives us negative 6. Negative 6 divided by 6 is negative 1. This, like I said before, also can be your R and your S for factored form. Okay, so let's say I was going to rewrite my factored form. Y is equal to, well, let's jump back to that other page. Oh, actually, I don't need to. I have the standard form at the top. Here it is. We know the A value for factored form is going to be 3. Okay. X minus, well, one of the values is 2. So this would be our R. We write in the number 2. And X minus, this is negative 1, so it's minus negative 1. So we might actually write this as, just to simplify it a little, positive 1. And if you remembered, that was the exact same one we started with. So just to prove that this worked, okay, and we did the quadratic formula, and we can talk about how we could have just factored this and made this a little quicker, and I'll show you another factoring method to do that. We're just going to double check to make sure this is the same quadratic what we've done. So 3x minus 2, x plus 1. So let's jump into Desmos. Here's the original one. We said y was equal to 3, x minus 2, I believe, x plus 1. And you'll notice this green overlays over the blue. We said one of the x-intercepts was negative 1 and the other one was positive 2. That's correct for our factored form, so that works out really nicely. Now, the quadratic formula might seem really complicated. You might say, hey, I could have very easily factored this using my normal factoring methods, but we can pull up a much more difficult question here. For instance, I'm just going to punch in a quadratic here. X squared. Oh, that's not what I wanted. Sorry, a lot of wrong buttons there. Minus 1x minus 6. Okay, not terrible. Let's say minus 5. Oh, that's a little better. Take a look at these, okay? So 2x squared minus x plus 5. I'm going to jump to another page here. 2, negative 1, negative 5. 2, negative 1, negative 5. 2, negative 1, negative 5. Okay? And remember, we could have done factoring on the other one. We could have came out to that answer. But when you look at this and it comes to factoring, this becomes a little more difficult. Depending on the factoring methods you use, for instance, I'm going to try to really speed through this because I know it's getting a bit long. This was the original question we had done over there. Another factoring method, we could have used something called like fearless factoring, where I actually write out the factors of the first and last term, 1 and 6, 2 and 3. I need their products to add up to the middle term, which is negative 3x. Technically, these have x's attached to them. And I just got to figure out which columns work, and then I set it up really quickly. So 1 times 1 gives me 1. 3 times 6 is 18. 1 and 18, I don't get any combination here. And I can do 3 times 1 and 1 times 6. Hey, that actually works out really nice. If I multiply this way and this way, 3x times 1, that gives me 3x. 1x times 6 gives me 6x. If the 6 is negative, that gives me negative 6. Boom, that worked out great. This is a method, I don't really know a formal name for it. We call it fearless factoring. These are my two columns. Great, I've set it up. So now I can just build my two brackets. I know 3x is going to go in one bracket and 1x in the other. And I just have to make sure it's opposite of what I multiplied by. So 3x was times 1, so I go plus 1. And that was times that. And remember, we had a common factor of 3, so we take the 3 out. X minus 2, x plus 1. Okay, so look at that. Hey, I could have factored the original one. I didn't have to do that ridiculous quadratic formula. In this one here, though, 2 times 1 and 1 times 5. I'm going to try to do my fearless factoring. I'm going to show you really quickly. 1 times 1 and 2 times 5 gives me 10 and 1. No combination of that works. 1 times 5 and 2 times 1 gives me 2 and 5. No combination of that work. You may say, hey, this doesn't work. This isn't factorable. But when I go to Desmos, I have x-intercepts, which means I can have a factored form of this. This is where the quadratic formula becomes really important. So we're going to try to go through this a bit quickly here. X is equal to negative b, okay? It's negative b, and that's negative 1, so we know it's going to be plus 1. Positive 1 plus or minus the square roots of b squared, so that's going to be negative 1 squared. Negative 1 squared is 1, so I'm trying to do this as we put the values in, okay? We're working a little quick here. Minus 4 times a, in this case a was 2. C was negative 5, okay? All of that is divided by, I can't do a straight line on these things to save my life. There you go. 2a. Remember, a is still the value of 2. Okay, we're going to try to simplify quickly again. 1 plus or minus. This becomes 4 times 5. Positive 20 times 2 is positive 40. So we get the square root of 41 over 4. Now, this is what our problem was. Square root of 41? I don't know it off the top of my head. Very luckily, Desmos can help us solve this quickly. Square root of 41. Okay, we're going to say approximately 6.4. So let's say the square root of 41 is approximately plus or minus 6.4. Okay, so this is where we set up our two equations again. We'll call it x subscript 1, the first root, and the second root, or the r and the s value if we're trying to go into factored form. So we end up with 1. We'll say plus in the first one. 1 plus 6.4. And we did a bit of rounding, right? It wasn't exactly 6.4. Divided by 4. And 1 minus 6.4. Divided by 4. Okay. 1 plus 6.4 is going to be 7.4. Divided by 4. I'm going to have to do that in here. 7.4 divide 4. 1.85, okay? 1.85. And in this one, oh, that's a funny 5. We end up with negative 5.4 divided by 4. Negative 5.4 divided by 4. Negative 1.35. Negative 1.35. Okay. I can make a factored form out of this. I mean, it's a little unorthodox. The a value, like we said, is going to stay the same. I get 2. I'm going to have x minus, in this case, my r value was 1.85. And x minus negative, so we know it's going to be a positive 1.35. Okay? So, if I write that in, I'm going to do my best over here in Desmos to write that in. Let's move this up so it's a little closer. We said y was equal to 2. X minus 1.85 and x plus 1.35. And if we turn it off, it is pretty much overlapping our purple one. Okay, let's turn off the other two so you see that. These are essentially the same. So I did find a factor form of this. Now, if we really zoom in close, there's probably a bit of a discrepancy because we did a bit of rounding. See, the purple one isn't exactly that, where our green one is a little different. But we've pretty much made it, without our rounding, if I left those as radicals or roots, I would have had exact values for this. So I could technically factor something using quadratic formula that my factoring methods can't actually factor. So it's important to know that.